Welcome or welcome back at C Square. In this lesson, in this video clip, we will talk about real numbers. And the first set I want you look at is what we call the natural numbers. 1, 2, 3, and so on. The next set of numbers is what we call the whole numbers. And you notice is the same as the natural number, but we have one more element, one more numbers in this set, which is 0. So obviously the set of whole numbers is larger than the set of natural numbers. The next set of number is what we call integers. Okay, and you notice we have the whole numbers plus these negative numbers, right? -1, -2, -3, -4, and so on, right? So obviously this set is a little bit larger than the whole numbers. The next set of numbers is what we call rational numbers, and those are the numbers you can express as a fraction. Of course, that b, the denominator, has to be different than 0. The next set of numbers is what we call irrational numbers, and those are the numbers that cannot be expressed as a fraction. Okay, so we'll see some example about that a little bit later. And finally, the real numbers is the set of irrational and rational numbers together. A good way to see this set of numbers is this Venn diagram. And you notice here, this is the natural, the smallest set of numbers, then the whole. If you remember, I said it has the extra 0. It's a little bit larger. Integers, the one that is larger than the other two. Rational. And take a look here. Irrational is totally separate. They don't have anything in common with the other sets of numbers. Altogether, we have the real numbers. So now we're going to take a look to this example where we have to name the set or sets of numbers to which each real numbers belong. So for example, this 7/13. This is a fraction, a over b, if you remember. So this is a rational number. But also you can call this one a real number. The best way to classify would be rational numbers, the smallest set that 7/13 belongs to. b, first of all, on b, I'm going to simplify that square root of 36, and that is 6. And then we can take a look, and this 6 is what? Is a natural number, but also we can call a whole number. We can call it an integer. We can call it an rational. And also we can call this guy a real number. The only thing we cannot call this square root of 36 is an irrational number, even though it looks like a radical, right? And most of the time the radicals are irrational number. In fact, if you take a look to see, that is square root of 10. That is what we call an irrational number. And if you want to see why, I would suggest you to grab a calculator and do square root of 10. And that will be a number like this, 3.1622, and it never ends. Okay, so that's the reason we call this one an irrational or irrational number. And beside the fact that never ends, they do not repeat this decimal. The last one, -17, that is an integer. Then we can call it also a rational, because it can be written as a fraction. And also we can call this a real number. Okay. The first name is the set that probably is the best way to classify the number. Okay, now let's move to the next part of the lesson where I said that numbers can be plotted on a number line, and for that reason I'm going to use this example where we have three numbers, A, B, and C, and we want to match them with a letter on the number line. And the first one is -5/2. I will use here a decimal form. 5 divided by 2 is 2.5, so I'm going to have -2.5, which means from this 0, see this 0 here, I'm going to go 2 units left. 1, 2.5. So that tells us this point B is the point that represents -2.5. What about B? First of all, let's simplify. I'm going to keep that negative, this one, and square root of 16 is 4. So what do we have to do here? We have to move 4 units left, and that will give us this point A. And now let's take a look to square root of 6. I think we should evaluate this. Of course, we can do, we don't really need that. You will see later what we can do. Let's use this method. So I'm going to do square root of 6, and this is 2.44. Never ends. If you remember, this is an irrational or irrational number. 2.44944 ever, which is around 2.5. So that means from this 0, I'm going to move 1, 2, and 0.44. That's the one, the best choice for our problem, E. The next objective of this lesson is to work with this repeating decimal. Like you see, this 0.77 can be written in this format, 0.7 with a bar on top. But this type of repeating decimal can be written as a fraction. Okay, so let's take a look how we do that. We're gonna call this number n, and I'm gonna write this form. Remember, this repeats forever. And the next thing I'm gonna do, I'm gonna multiply by 10 both sides. So I'm gonna have 10 times n here, and on the other side I'm gonna have 10 times 0.555 and so on. So we're gonna get here 10n, and on the right side we're gonna have 5.555 repeats forever, right? Okay, and now I'm gonna subtract n from both sides. So from here I'm gonna subtract n, and from here I'm gonna subtract n, but I'm gonna use this form. Okay, and let's see what we get here, right? The left side becomes 10n minus n, that is 9n. The right side, 5.555 minus 0.555, that will be 5. And I want to solve for n, so we're going to divide by 9. And we have a fraction for the number n. That is 5/9. So grab a calculator and take a look if 5 divided by 9 will be 0.5555. It does. Okay, this is the simplest form for this repeating decimal, how we call it. My next topic will be about square roots, and we notice here I say square roots can be simplified if they are perfect square. If they are not perfect square, we can estimate them. And let's take a look to this example. On this one, we can simplify square root of 121. We're looking for a number that raised to the second power is 121. And that number will be 11. 11 times 11, 11 squared is 121. So square root of 121 is 11. What about the second one? First of all, notice you have that negative, which you need, so we're going to keep it. And then I'm going to look for a number that raised to the second power is 16/49. And the easy way is to break the problem. What do I mean by that? One number raised to the second power is 16. That will be 4. One number raised to the second power is 49. That will be 7. So our answer here is going to be -4/7. Of course, you can use a calculator, but I would like you guys to try to do this without the calculator first. And the second part, we're going to estimate square root to the nearest whole number. So let's see how we do that. So you notice that square root of 24. Now I'm looking for two perfect numbers that are close to 24, and one of them is 25. All right. Okay. And the other one is 16. These two numbers, 16 and 25, are perfect squares. 4 squared is 16, 5 squared is 25. Now I can take square root and keep this inequality you see here. Square root of 16 is 4. Square root of 24 is the number we want to estimate using this technique. And square root of 25 is 5. So that tells us this square root of 24 is a number between 4 and 5. And since this 24, it's pretty close to 25, right? I will estimate this one as 5. Let's take a look to the second one. Square root of 125. Okay, so a very close, perfect square number to 125 is this 121, right? You notice. So 121, and which is less than 125. And another closed perfect square, the next one is 144, which is 12 square. Again, I'm going to use the same technique. I'm going to take square root, and I'm going to have here 11 less than square root of 125 less than 12. So looking now here, we notice square root of 125 is a number between 11 and 12, and of course, since 125 is closer to 121, I will approximate this one as 11. My next topic will be to compare this real number, and I said here you can compare them using a number line and using this inequality, less than and greater than. Now this is the sign I will use for this next example, but also I want to be sure there are two signs that are very close to this, less or equals to. You notice the equal sign here, greater or equals to. Okay. So let's now take a look to this example, and we need to compare 2 and 3. Okay, so, and I said we can use a number line. What do I mean by that? If you draw a number line, and I'm going to put 0 here, the number 2 is going to be right here, and the number 3 will be the next one. Since 2 is closer to 0 than 3, we're going to say 2 less than 3. What about the second statement, B? On B, you need to be careful. I'm going to use the same approach, 0. Negative 2 is this, gentlemen, and negative 3 is the very next one. And since here, negative 2 is closer to 0, but is on the negative sides of the number line, we're going to say negative 2 is greater than negative 3. So be careful how you judge this inequality sign. Part C, 0.1, 0.05. So we have that 0 here, that 0 here, but then we're looking to this digit 1 and 5. 1 is less than 5, so I'm going to say 0.1 is less than 0.5. Very similar, part D, we're looking 8, 8, 3, 3. And the next thing we see 5 and 0. 5 is greater than 0, so 8.35 will be greater than 8.305. On part E, we're looking to fraction, and on this part E, you notice they have the same denominator. The bottom of the fraction is the same, 4. So now we're looking and we notice 1 is less than 3. That means 1 over 4 is less than 3 over 4. Of course, you can use a calculator and get a decimal value, but I don't think we need to do that. What about F? On F, you should notice we have the same numerator at the top of the fraction. And then we notice on the first one we divide by 5 and the second one divide by 7. This is kind of backwards. You divide by a smaller number the same number. That means we have greater here. 5 is less than 7, but this one switch. So we have 2/5 greater than 2/7. Okay, even though the 5 here is less than 7. And the last one, we have two fractions. They don't have the same denominator. They don't have the same numerator. So what can we do here? First of all, we may want to change this in something that we call equivalent fraction. And how do you get the equivalent fraction? We notice this 4 and 6. The least common multiple would be 12. So you notice I changed the denominator from 4 to 12. 4 times 3 is 12, and 3 times 3 will be 9. That's the way you get this numerator. Similar, 5/6, I'm going to find the equivalent fraction. The equivalent fraction that has a denominator of 12, right? 6 times 2 is 12, and 5 times 2 is 10. So now I'm looking to 9/12 and 10/12. Obviously, 9/12 is less than 10/12. You notice they have the same denominator. The numerator 9 is less than 10, so that's the inequality that we have to use. But remember, 9/12 is 3/4, and 10/12 is 5/6. So that is the inequality we have for this part. And the last topic in this lesson is to arrange a group of real numbers. And I'm going to use this example where we have a list of numbers and we have to arrange them from smallest to largest. So let's take a look to A. And if we take a look, all of them, they have 3. But the smallest one will be the last one, 3. 3 will be less than which one? Now, if we take a look to these two numbers, the smallest one will be 3.005. Why? Because this 5 is the 1000th digit. And then the largest one is 3.05. Since that 5, this 5, is the 100th digit. What about B? 1/5, 1/7, 1/3. So here you can use a calculator, or you can look, hey, I have the same numerator 1. And then I see 5, 7, and 3. Which one is the smallest? 1/7, because you divide 1 by the largest number, 7. Which one will be the next one? 1/5. And the last one, the largest, is 1/3. C, if you notice on C, we have the same denominator, 7. So we're looking here and we notice the smallest number numerator is these two. So that will be the smallest rational number, 2/7. Then the next one will be 4/7. And the last one will be 6/7. Again, we can check this by using a calculator and change this in a decimal. And the last problem in this presentation, in this lesson, will be D, where we have to rearrange these three numbers from smallest to largest. So very similar to what I did in another example. I'm going to change this fraction in equivalent fraction. And I have 3, 5, and 7. They have nothing in common. So the least common multiple will be 3 times 5 times 7, which I think it's 105. Well, let me check. And yes, it's 105. And 3 times 35 is 105. So here we have 1 times 35. So we have 35/105 as an equivalent fraction. Let's move to 2/5. And again, I want to change in a denominator of 105. 5 times 21 times 5 times 21 is 105. 2 times 21 will be nothing else than 42. So the equivalent fraction for 2 over 5 is 42 over 5. And let's go to the last fraction, 4 over 7, where we have to change and get this 105. And 7 times 15 is 105. 4 times 15 will be 60. So now we have this equivalent fraction, and you notice we have the same denominator, 105, 105, 105. So which one is the smallest? The smallest is this one because the numerator is 35. So now we're looking, the equivalent fraction is 1/3. Yeah, this is the smallest one. Then the next one is 42 over 105, and 42 over 105 is 2/5. And the last one is 4 over 7. This is the largest number. Of course, you can grab a calculator and check it if that is possible. And that's it. Thank you for this lesson, and I looking for you to be back on C Square.